Hello, it's Eric here, and in today's thought experiment, we're going to look at the arrow of time, and then so as we all know, the arrow of time always flows from the past to the future. You always go from the past to the future. It's never the reverse. You cannot say the future will happen first, and then the past will happen later. It doesn't happen like that. And then so therefore let me rearrange it, and then we get the original configuration where the arrow of time always flows from the past to the future. And then so then the question is why? Why does the arrow of time always flow from the past to the future, but not the opposite direction? And one of the best explanations that I've heard is from Sean Carroll. And then he said that the arrow of time goes from the past to the future because of the second law of thermodynamics. And the second law of thermodynamics states that the entropy of a closed system, like the universe, is always increasing. Yeah, that means you always go from a low entropy state to a high entropy state. Yeah. And then so then you may ask, well, how do you know that the universe starts from a low entropy and then it progresses to become a high entropy state? Well, the one of the best evidence for that is actually from the CMB radiations, the cosmic background radiations. And it seems that the CMB radiations, no matter where you look in the universe, the CMB radiations seem to have a very uniform distribution. Uniform distribution in the sense that all the CMB radiations in all corners of the universe appear to have the same frequency, same wavelength. Yeah, and then that can only happen in a low entropy state. I mean, it can also happen in a high entropy state. If it happens in a high entropy state, that means high entropy state. That means the CMB radiations in different corners of the universe may have wildly different frequencies and different wavelengths. Like for example, if you look to the left, the CMB radiations may have a very high frequency and a short wavelength, whereas if you look to the right of the universe, the CMB radiations may have a very low frequency and a very long wavelength. Yeah. So in a high entropy state, the CMB radiations will be wildly randomized. I mean, it can also happen that in a wildly randomized high entropy state, you can also observe that the CMB radiations from all corners of the universe have the same frequency, same wavelength. But that is a very, very low probability event. Yeah. And it's such a low probability event that if you still observe it, that means it's probably the case that the entropy in the past for the universe is not of a high entropy state, but of a low entropy state. And so therefore, if you accept this argument, then that means the entropy started in the universe in a low entropy state, and it flows to a relatively high entropy state like now, yeah, as of now, yeah. And then it turns out that this is the explanation why the arrow of time always flows from the past to the future, yeah. All right, so I think that argument convinces you. If not, then let me know, and I'll find another argument to convince you. Yeah. All right. See you then. Bye.